Hello, everyone. Welcome to the AMT Tech Trends podcast, where we discuss the latest manufacturing technology, research, and news. I am Benjamin Moses, the Director of Technology, and I'm here with amazing
Stephen Lamarca, Technology Analyst. Thank you, Ben.
You're welcome, Steve. On this cold, rainy day in
Cold,
Virginia.
disgusting day.
It was a miserable part of winter.
And we needed it.
I need a good cleanse.
Yeah.
Steve, I know you're a big Formula One guy.
Yes. Well, I mean, it's tapered off in the years. In college, I was big into Formula One. And then I made the beautiful transition to follow. Oh, and a lot easier to follow, by the way. Actually, that's debatable. Made the transition to Le Mans racing. But no, let's talk about Formula One real quick. I'm really dating myself, and it makes me feel old now because I'm a big fan of high revving, naturally aspirated engines that tend to scream and shriek.
Yep.
High pitched engines.
You like the audio side of Formula One.
Yes. I love that sonorous scream, the wail of a Formula One engine.
Right. Even through the TV, it sounds amazing.
Even through the TV, it sounds amazing. You put on some open back Sennheisers, even better.
Even better.
But since probably the early 2010s, whenever they implemented this dumb turbocharged V6,
right,
everything went to poop.
Fairly recent.
But all right, let's go back around the era of when Brett Favre killed the stock market, like 2007, 2008.
You want to explain that real quick?
Yeah. So everybody thinks everything went downhill in 2007, 2008 because of the stock market crash.
Right.
Well, why did it crash? It crashed not because of bankers selling things to Ireland or whatever, they claim it was. I don't know finances. I'm not going to claim to know that stuff.
Nobody does.
It was because of Brett Favre. Brett Favre for 2 years straight was like, oh, I'm going to retire. No, I'm not going to retire. I still want to play. But, I'm getting kind of tired and I got some gray hairs. And, I got this deal with Wrangler jeans at Walmart. But, no, I'm going to keep playing. No, I'm going to retire. That went on for 2 years straight.
Yep.
And it covered up not just ESPN when I was trying to learn about this new kid in Formula One, Sebastian Vettel, who was just dominate. People totally forgot about Mercedes-Benz and Ferrari.
Yep.
And we're like, why does an energy drink team have a dominating Formula One team and, an up-and-coming Formula One team? And who is this kid Sebastian Vettel from Germany?
Yep.
Is he from Germany?
He speaks German, so I would assume so.
I think it's German.
Yeah.
And no, we couldn't know any of that because Americans know nothing about Formula One.
Right.
And I was I feel like I was up there. I was getting a lot of news from the internet.
Yep.
And I thought it was a big deal when, and my roommates in college at the time, my roommate Chuck is huge Yankee fan, still is. He was so ticked at ESPN because 2007, 2008 were incredible years in the MLB. Yep. Incredible baseball seasons.
Right.
But you wouldn't know because Brett Favre was dominating the news.
Yep.
And okay, let's stop talking about sports.
Let's get back to Formula One.
No. Let's talk about what happened in that. The reason why the stock market crashed is because everybody was being updated in ESPN and just the news in general about what Brett Favre is going to do. And all of these shareholders and stockbrokers weren't able to stay up to date with industry newses and stuff. So everything, when money started moving, they couldn't keep track of it because all they knew was Brett Favre. And that's why the thing crashed. And that's why everything went to poop.
Thanks, Brett.
Thanks, Brett. And because of that, Formula One went from these 2.7 liter screaming V8, 2.4 liter V8s, high rate, 16,000, 19,000 RPM, to turbo inline sixes, or not inline six, V6s that sound like vacuum cleaners. They sound awful. Yeah. It's been almost a decade now. I want to say it's been at least a decade. Right. It's been at least 10 years. Yep. And they still sound awful. And to add insult to injury, the cars even got ugly too. They were they looked like there were a few Formula One teams that not only did like the cars just, it was like we reverted back to the 80s where everything was designed with a straight edge ruler and cocaine to it wasn't even that, because at least that had some excitement to it. There was the cocaine, you know. The Formula One cars just looked like a child with a ruler and looked down at his or her pants, saw genitals, and put it on the front of the car.
There was a lot of genitalia.
Like, it was really gross. Like, those cars were hideous in the early 2010s.
Yep.
And on top of that, they sounded awful, and they still sound awful. But the good news was in 2019, when the world was only starting to go back to the status of being awful again, Formula One decided, hey, this is the next layout, or this is the next template, the design template for the next generation of Formula One cars. You know, you teams get ready to start designing your cars to look like this.
Right.
And 2022 comes around. That 2019 concept car is now being implemented.
Nice.
Formula One cars for like the longest time have had these like minuscule, like 15-inch, 14-inch wheels.
Right.
When no car in real life has a wheel that small. Now Formula One cars still finally have like a 17, 18-inch wheel on them, which look really nice.
Right.
And it's cool. So the styling is there. The next step is the engine, but I have a feeling I'm not going to get my hopes up.
No.
With gas prices the way they are. We're not going to have any high revving, wailing engines anymore.
I filled up the car this morning, almost hit triple digits.
Dude, it cost me $15 to fill up the motorcycle yesterday. I've never spent more than $8 to fill up a tank on a motorcycle.
I went through my own struggles this past week. I bought a new red dot for one of my pistols.
Okay.
I went from a fairly inexpensive one to experiment, try out red dots, to something higher end, like a Loophole. Went to the Loophole Delta Pro. Fantastic looking, just holding it. It didn't come with mounting screws because that's part of the mounting kit. Depends on the mounting kit that you have. So the mounts that I couldn't find any screws in my house, so that were that correct length. So I go to Home Depot to check the threads that I have on the mount itself. Figure out it's a number 4 thread, number 4x20, I think. Look around Home Depot. They gotta have screws. They had the thread checker there. No, the small size I have is number 6. This is going to be great. So I'm putzing around. I spent a half hour because like if you have a thread checker there's got to be a number 4 screw. Nope. So went back to the house, and of course these are countersunk screws. So I was checking the length of the one that came in the package. The one's not going to fit, but the overall length that should go into the mount. So I thought I had that length correct. Ordered something on Amazon. I went for the slow shipping because I'm trying to package all my stuff together, not have 10 packages delivered different days. So the 1/2 inch length that came in, put it through the red dot. Didn't make it through the red dot. Didn't touch the base.
Jeez.
I don't know how he screwed up the length. So I placed another order for the next size and the next size above that. So I have 50 screws of number 4 that's 1/2 inch long that I'm never going to use. I've got 2 packages of 10 that I'm probably going to use 2 of those. So I'm going to have a 20, 18 more screws laying around that I'm never going to use.
Yeah.
This is fantastic.
So as we all know, I went through a similar thing with the robot arm recently. I think we talked about this the last podcast, so I'm not going to touch on it again. However, like I totally feel the screw thing. And my first question before I go on is, did you try contacting the red dot manufacturer to be like, hey, could you send me another set of like the screws that came with this thing?
No, I didn't try. So I looked on their website. So I looked at the mounting plate company.
The mounting plate.
Yeah, they would have had that. So I checked the website to see if they had enough information. They didn't have thread. They didn't have the thread size and pitch, and they didn't have recommended screw lengths. They recommended the screw holes, but they had a list of their red dots, and they had recommended hole locations. And but they didn't have any information on what length you should buy. So it was a little frustrating on that. I could have called them, but I don't like calling people.
I've got 2 more screw stories for you. And don't worry, it's not that kind of podcast. But I recently, for Christmas or my birthday, I forget which one it was. They're both around the same time. I I got a second hard drive. I got a 2 terabyte for my gaming rig.
Nice.
And I open it up.
Yep.
I have Sean, our IT guy, come over to my house because we're that awesome. And he helps me with installation because I got to move the graphics card out of the way. I got to take that out to get to the NVMe M.2 Gen 3 slot and to plug in the SSD. And the standoff is there.
Yep.
There's no screw in the standoff.
Of course not.
So we call it a day. I contact Corsair, who build the PC, and they also make the case that all the components are in. Like, hey, could you send like a hardware kit? Because I want to expand the hard drive capacity or the storage capacity, and I'm missing a screw for the standoff.
Sure.
They send me a kit. About a week goes by. I get a kit in the mail. It comes from all the way from China. I have the tracking number and everything. Get the kit in the mail. It's got a screw in there. It's not the right screw.
Of course,
it's got all this other stuff too that I do not need. But the one standoff screw in there isn't the right screw.
That's a bummer.
So I probably shouldn't be telling you this. Sean and I are just like, okay. Well, Sean's like, okay, we're going to the office. We go into the IT storage room.
There's some surplus
he opens
hardware.
up 2 dead computers that need to be parted out anyway.
Yep.
And we get some standoff screws. They fit perfectly in the PC. He got 2 of them just so because the original hard drive SSD that came on the computer has a chrome screw. Screws in the IT office are black.
Black oxide.
They're subdued.
Yeah.
So you're like, we're getting 2 for consistency. We're going to swap out the other one too. So he does me a solid.
Yeah.
Other story number 2. I totally feel the pain. I'm collecting action screws for my Remington 700 right now.
That's fun.
Because none of them are standardized.
Really?
Every single pair of action screws has a different length.
Yeah.
Red Hawk Rifles, the company that you like, I ordered a set of action screws from them. They're like, we're going to send you these long screws and it's going to be your job to cut them down to the length you need. And it's like, I don't have this technology.
That's a fair proposition if you have the tools.
Yeah. So I like you, I have a collection of sets of action screws for the Remington 700. And I've just gone with the best fit right now.
Nice.
The front action screw still quite isn't long enough. Like when you open the bolt and you look into the chamber, the lug area, you can see that I'm still missing a few threads.
Okay.
And with a 30-06, you want as much thread contact as possible. So yeah, we've talked. Big Screw is almost as bad as Big Pharma in the food industry. This is terrible. If you work for Big Screw, I hope you never have another cold beer in your life.
See, let's get in some articles, man.
Let's do it.
I got one on Doug actually wrote a pretty good article that we posted on AMT Online about the consistency of change and transformative technology. So it's a good look at where we are as a manufacturing technology industry, right? So the rate of new technologies being released is mind-boggling. Our feeds are constantly blowing up with new machines, new modifications, new machines, and tangential technologies being brought in. So a couple of quotes here. While machining in the macro may be the same process it was 20 years ago in any given operation, it may be entirely different. Everything from the chemistry of the inserts, we've gone from significantly different materials on that side, and coatings, to the capacity of spindle drives, control algorithms for each of the different axes. So even a big machine, break it down into small components, changes throughout the entire machine, right? Even the coolants, the rate of change of you trying different coolants also, it's throughout the entire article. And, a good use case, right? So if you talk about the technology, that's fine. But if you're using technology, what does that actually mean? So Doug also talks about the concept of rapid prototyping. If you look back, Doug keeps using the term 20 years. That's half my life, but fair point because I was early in the manufacturing industry then. So 20 years ago, if you said, I need to rapid prototype something versus if I need to rapid prototype something now, the definitions are completely different. So one of the use cases were back in my previous company, we had a welded assembly and there was a casting on the end. So we had to verify that the tooling of the fixture for making the weld assembly was correct. When we needed mock-ups. So we had, elbows, tubes that we had in stock that we could rapidly prototype to see if this thing fixed. But we also had a casting on the end.
Okay.
The casting lead time was like a year.
Really?
It was really long just to get in the queue, get the material, get the
That's almost as long as the X-Arm 7 from your factory.
It's outrageous. And it was early in the development cycle. So this is a new casting we had to make. But we're not going to wait for a year to see, okay, this thing might work. So we 3D printed the casting, the final version of the casting, and we put that into the fixture. And we printed several different versions to, account for the tolerance variation that we're concerned about.
Yeah.
That cycle, took a week or so.
But just a mock-up of the casting,
just
right?
a mock-up, yeah.
Until the year-long one
right.
actually arrives.
Exactly. We're dealing super alloys. We're not going to print a casting out of plastic and ship it. But the idea of a rapid prototype of testing something, right, that took a week. 20 years ago, how would you have mocked up the casting? You'd have had some machine components.
So you guys actually did that?
Yeah.
That's sick. How much did that cost?
We had a Stratus 3D printer in-house.
Okay.
So we just paid for the material. The printer that we had was like the $75K range.
Gotcha. Okay.
So it's a great experiment. I mean, it's exactly what we bought that machine to do, is do things very quickly as fast as we could on the manufacturing floor, right? So we weren't doing production through the printing, but the idea of being able to rapidly test something or prove something, that's where we are today. The big takeaway is the time to manufacture, time to market, is significantly shorter than it was, decades ago. And that's a big takeaway, right? It's our adoption and our implementation for new technologies has become a shorter cycle, right? So, if you're in a manufacturing world, if you're a manufacturer, what does that mean, right? Either you're constantly on the lookout for new technologies to make you faster, make you, in a lot of cases, more accurate, more resilient, but also ways to constantly harvest value, right? How do you get to a faster manufacturing process? How do you reduce your lead time to start cutting chips, or how do you cut chips faster? So it was a cool article. I thought.
I like his title.
You like the title?
Yeah. The consistency of change in transformative technology. Consistency of change. What's the doc from Back to the Future? What's that guy's name?
Oh,
the character's name?
I don't know.
With the flux capacitor?
Oh, Doc Brown?
Doc Brown.
Yeah.
Okay. Doug is acting like Doc Brown right now with that title. The consistency of change. That's his flux capacitor. He's trying to capacitate the change in something.
Do you think Doug would appreciate being called Doc Brown?
Yeah.
Okay. We'll try that later, since it's just us three in the office.
Okay.
If he yells at us, I'll hear it.
I guess we'll find out in about a week when he listens to this. If he can get past the spiciness from our banter.
You got an article on robotics?
Yes. All right. Which one? Let's go with the first. Let's go from left to right.
Yeah,
okay.
Let's do that.
So this first one is from Unite.ai. I don't think I've ever read an article from this website.
Okay.
Full disclosure. Flexible robotic arm guided by AR goggles.
That's cool.
Ben, we are so trend setting.
Sure.
Like, our last episode sponsor, AM Radio.
Yep.
By Gardner Business Media, with Stephanie Hendrickson and Pete Zielinski. They had an episode of their podcast 4 months ago that was titled "The Additive Manufacturing Industry is Being Directed. The development and advance in that industry is being led by curmudgeons." That's us, bro.
We're the curmudgeons.
We're the curmudgeons. And but to get back to trends that we're setting, not just following, you just published an article, or maybe you submitted the article, but it's going to be published soon of what the heck happened to AR?
Yeah.
What's going on with AR? This is the freshest article. This is the freshest evidence we have now. The article's already been submitted, and somebody's read it and decided to do something with it. But what do you think of this? First off, flexible robotics are really cool. flexible arm. So they're trying to imply a industrial application using an arm. And then because there's just not enough buzz going on, they want to implement AR goggles to help control this robot.
There's a lot going on in this article.
There is so much going on that I think we should just stop there and move on to the next article.
Well, I do want to differentiate one thing, right? So flexible versus soft robotics, there is a subtle difference there that I think audience should be aware of, right? So I think, right? So
get us learned.
A standard robotic arm has specific joints where you have a motor and it only bends at that one point. When you go to the extreme of soft robotics, the entire arm is movable, but they use either a liquid or a gas, right, in pockets, and it moves kind of like a bug at some point, right? When you look at flexible robotic arm, the entire arm is flexible,
right,
but it's more rigid than soft robotics. So that's where we get into that industrial space. It's a middle ground between, the hard rigidity of jointed robotics versus the softness of soft robotics. So I think that's a subtlety where, and then the integration of AR, right? So I think what they're trying to do is, you could do remote teaching of the robotic arm in a more natural way. So you're not limited by the joints on the arm. You're limited by the flexibility of that robotic arm in this case.
The thing that boggles my mind is, last week we had Andra here of Silicon Valley Robotics, and she mentioned to me in a meeting and other people that were also in that meeting that the common upper limit that you typically see on robot arms, both industrial grade and like collaborative, is really 6, maybe 7 joints. But we know there are a few companies that offer 9 joint robot arms.
Right. Infinite amount joints.
Does a flexible but not soft robot, but a flexible, is it actually flexible, or are there like actual joints in there that just there's too many more than what's worth documenting?
There's different ways to quantify the flexibility.
How does the arm move?
Good question. We'll read the article and find out.
We should try that next time.
So it's an emerging technology. Not a lot of people have adopted flexible robotics. I think it's worth exploring how these things work.
Not a lot of people have adopted AR. It's a match made in heaven.
All the fair points. Steve, cool. I've got one on Additive and your favorite company in the world, Sennheiser.
Yeah. All right, man. All right. I thought you were about to troll me.
No, that's for later in the afternoon. So Sennheiser launches metal 3D printed IE600 earphones. So IE600 is their model.
They're IEMs, not earphones.
In-ear monitors or earbuds for the layperson. That's a troll.
Don't you? They're in-ear monitors because they go in your ear, and they were originally developed so musicians could monitor what they're playing and what their particular instrument, if they're in a band, sounds like, while the actual speaker cabinets that they're playing for the audience are cranked way up and blasting and melting their faces. They can still hear exactly what they're playing to make sure what is melting the faces of the audience still sounds good.
That's right.
Which is why it's an in-ear monitor.
And we've talked about 3D printed in-ear monitors before. The
this
variation
is very common.
The variation here is the housing for these monitors are metallic. So the 3D printing metal.
And this is a consumer good. A mass-produced consumer good. I'm going to look up the price on these right now, because I bet you they're probably $1,000+.
So they use an interesting material since it's electronics and it's wearable electronics. They use zirconium. Not too familiar with that. They use a special grade from
zirconium nitride.
No, it just says zirconium.
Zirconium. Okay.
So interesting, and they use Trump lasers for their system. So it's a cool article.
Very cool
article they talk about, and obviously, if 3D printing, you're going to have to require some kind of finishing because you're inserting electronics into the housing. So they're finished mostly by automation, but they are including some hand finishing also because it's so small.
You can see the layerings in the product.
Yep.
Like when the actual had the actual picture up.
Yep.
That's a rendering. which is why it kind of looks all pimply, not pimply, but there you go. There's the layering.
Yep.
That's beautiful.
Yeah, we'll include a link in the description. So I thought it was a cool article that, one we were getting to.
They're not using balanced armatures. This is a 10 millimeter dynamic driver.
That's great news, I think.
Words.
So interesting material choice and, mass producing. It's fairly small, right? It's an in-ear monitor.
Yes.
It's not, the big headphones that I like to wear, but, I think it's a great take, and we'll see what the future looks like for Sennheiser. And Sennheiser is known to produce high quality goods for both professionals and consumer grade equipment. Right. So,
and there's a few cool takeaways here. So number one, and most important to us, this is metal AM being used for mass production. These are not custom fit IEMs. Correct. These are mass produced IEMs, which is awesome. I'm a article is about to be published that I authored about how, additive manufacturing is by no means an emerging technology. It has emerged. It's here. You were just talking about how in your last job, you guys 3D printed a mock-up. Now that was a mock-up, and we've come a long way from mock-up since then. But you worked for Eaton, a huge company that had already been implementing additive manufacturing, not necessarily for production, but for prototyping. Right. Which is still a big deal. Stop calling it an emerging technology. Additive is here.
Right.
And this is further proof on the consumer level.
Yep.
And not a mock-up. This is mass production of a final product. That's sick. That's really awesome. Number two, my second cool takeaway is, like you mentioned, additive manufacturing, at least for polymer additive manufacturing, thermoplastic additive manufacturing, has been used for a long time now in earbuds manufacturing for both custom fit, mostly for custom fit, and not just like SLA or SLA is used a little bit, but I digress. This is the first case of metal additive, at least that I know of,
for
in-ear monitors.
Not a lot of metal in in-ear monitors in general. I think they've shifted away from that. So,
acoustically speaking, one of the beauties of using a metal is you're adding weight to the product.
Sure.
Then that may cause discomfort for the user long down the road, but typically weight is really good for acoustics in terms of minimizing reverberation, or at least unwanted reverberations, or like in the case of exhaust systems, drone. Weight is always a good thing. That's why titanium exhausts always sound really raspy and gross.
Right.
Is the weight reduction worth it, bro? But like for in-ear, this could be. I bet you these have a really warm sound to them.
Why don't you buy some and find out?
Hold on. Let me. I still haven't found a price, so I might need to ask for a raise.
This could be a problem. We'll spend all our podcast budget on in-ear monitors.
But here's the frequency response curve, and it's a nice V-shaped curve.
Nice. Let's get into the next articles.
Which is definitely for a consumer.
Yeah.
Because typically for a musician, somebody who's using in-ear monitors for actual monitoring wants a flat curve.
Yeah, that's the dilemma I face. A lot of the stuff I buy at home for my home use, audio wise, is very, very flat. When I come to work with, I use my Sony headphones, and it's got a different curve. I'm torn if I still like the flatness of it, or if I like the natural sound that's straight from them, or a little boosted from.
Sometimes you do just want some subtle, gentle coloring to your audio.
Yeah, coloring is the right word. Tell me about your next robotics article.
Next, all right. So. Not necessarily robotic. This is about metrology from my favorite source, Metrology News. The article came out March 7th, 2022. Shaping the future of CMMs, coordinate measuring machines. This was really cool because in the first paragraph, the opening paragraph of the article, they say CMMs have been around for a long time.
Right.
Roughly 35 years.
Sure.
Which is cool and also crazy. Yeah. It's like how foundational this technology is to manufacturing, especially manufacturing good stuff. And they talk about how it's really bulky technology.
Sure.
And it takes up a lot of floor space and real estate and headroom. And at first I realized, or I was thinking to myself, I was like, every single CMM I've seen
right.
is actually not that big. It's about the size of like, a table or a desk.
Sure.
And then I realized, well-written article goes on in the second paragraph to clarify. Yeah, they're not that big.
Right.
But they need to traditionally speaking, they need to be secluded from the rest of the factory or the rest of the environment that they're in. They need to be in a lab, not necessarily clean room, but they need to be in a separate room from where your 5-axis CNC would be.
Temperature variations is detrimental for accuracy in that case. Yeah.
So this article is really cool because, again, the title is Shaping the Future of Coordinate Measuring Machines.
Mm-hmm.
They're highlighting the drive for all of these CMM manufacturers and metrology manufacturers, contact-based manufacturing, manufacturers of CMMs, and not just CMMs, but the Renishaw equator, I don't think it's not technically a CMM, but it's also a CMM. It does what a CMM does.
It's a contact.
But it's just like it's a delta arm version of a CMM, where a CMM is typically like, a 3-axis gantry.
Right.
But a lot of these companies are working to develop CMMs that can work on the shop floor.
That's cool.
And a lot of them are selling solutions. Like, so you don't just get the CMM, but you get a CMM and a robot.
Oh.
And the robot is designed to take your part from the machine and put it on the CMM for you.
That's clever.
Which is great for repeatability, which is very important with metrology and data collection. And that's basically where the article was going. They mentioned a lot of companies and their modern forward-thinking solutions.
Yep.
This was just a really fun article.
That is.
And
it is cool getting a part that's verified out of your cell, right? So if you're running a couple of machines, right? So even if you're just running one machine, knowing that this part is good when it leaves your cell, that's an amazing feeling, right?
Right.
Not having to wait, a couple of days because it's got to get queued to the inspection lab and then get the results later, and the supervisor comes to yell at you that you're out of spec. You could have modified a program 2 parts in.
and think about like the amount of logistics that this is cutting down.
Yeah.
Because we've talked a lot about in the past few years, I want to say, about closed loop or integrated metrology in a machine. Well, yeah, you can put a touch probe in a CNC machine, but it will never be CMM accurate.
Right.
But also, you just mentioned, like, once a part's being done or done being cut, you have to send it to inspection. Well, why does it got to go all the way to inspection and then you find out it has come all the way back from inspection that it failed?
Yep.
Why doesn't every operator, technician, machinist has probably thought at some time in their career, why does an inspection come here and get it?
True.
And those companies have answered the call, and they're like, forget closed loop inspection, forget sending it to a different room in your facility.
Yeah.
How can we get metrology closer to where the action is happening?
One subtle thing that I hope people also consider, the automation side of it is fantastic. But there are some subtleties once in a while. So, for example, you may have to clean the part before you put it on the CMM. You have to make sure that your program includes like deburring and all the radius and things like that. So there's a couple of subtleties there, but overall, that's fantastic.
See, also, I love this one picture in the article of like this big FANUC arm.
Yep.
Putting something, barely being able to fit into a Renishaw equator to put something in place.
I like that.
You see the little UR robot on a hexagon solution. Oh, another question I had. Where is it? The Zeiss Duramax.
Yeah.
Which Duramax came first? The Chevy diesel engine or the Zeiss? Chevy. I think they should duke this out.
I think so. I'll put some calls in. We'll figure this out. See, the last article I got is a good one, I guess. It's to know the government is investing into manufacturing. Commerce Department awards $54 million in American Rescue Act grants to increase access to advanced manufacturing opportunities. So this is being funneled through NIST, National Institute for Standards and Technology.
Nice. How much money?
$54 million.
Going to the America Makes Institute?
Well, I'll get there in a second.
America Makes.
Don't jump to the conclusion, Steve.
Okay.
So yeah, they're awarded $54 million for 13 high impact projects research development and test beds for pandemic response. So they're obviously looking at what they've learned from the pandemic and how to continue moving forward because we're still in a pandemic. The funding was provided by the American Rescue Act, which supports projects at 8 manufacturing innovation institutes. Yep, your manufacturing USA institutes.
Gotcha.
Working with more than 80 partners. So I got a couple of the projects that they and the institutes that are working on. Obviously, there's stuff on big pharma on there, which I kind of glossed over. I'm not too interested in those, and audience probably.
What are you doing?
ARM out of Pittsburgh, PA, Advanced Robotics and Manufacturing. They got almost $5 million to create the robotics and automation decision framework for agility and resilience. I don't know what's going on with that title, but to allow small and medium-sized manufacturers to systemically evaluate cost-to-benefit ratios for integrating robots. So basically a spreadsheet that answers your question, should I buy a robot? And that'll always answer yes.
Yeah, better.
MXD got $3.8 million to create drug product marketplace orchestrator.
3.8, you said?
3.8 million.
Okay.
Actually, they got 2 of them, so they had a great marketing team. The first one is a marketplace for consumers and manufacturers of emergency health and medical goods to ensure rapid responses across the supply chain is met demand for particular items. So they're basically, orchestrating who has needs and who can manufacture goods, right? So if you have a sudden need for face masks or something else, right? You put a need in the system and manufacturers can pull that need and manufacture on demand. American Makes actually did this early in the pandemic with some of the either test equipment for the virus or protective equipment, right? They asked hospitals what their needs were, what face masks are looking for, and manufacturers had their designs. They had kind of an open marketplace where they can pick and choose. And then the FDA got involved in kind of saying, yeah, this is okay, right? It's not truly certified, but it'll work in this pinch.
Right.
So it's kind of interesting. Good orchestration. The second one they got was $2.3 million to create a privacy protecting local health alert system to conduct contact tracing analysis.
Oh, cool. So that's when your phone pops up and be like, hey, do you want to activate this app that we installed for you behind your back?
Exactly. But they want to test it out using blockchain. So
of course,
we'll see.
Good marketing again.
I'll go on record saying I'm not a big fan
of blockchain. I'm a fan of everything we've mentioned so far until blockchain.
The last one I got is our favorite, America Makes. They're out of Youngstown, Ohio. They got $3 million to use additive manufacturing to create prototype of N95 level non-woven filter material.
Wow.
For respiratory.
How much did they get?
$3 million.
All right. We're still shy of 54.
There's a bunch of other ones.
Oh, okay.
There's
but these were the fun ones.
These are the fun ones that I like. There's 13
we don't pick
projects.
favorites, Ben.
I do.
Okay.
Steve, how can they find more info about us?
You can find more info about us on amtonline.org/resources. Subscribe, unless you're Big Screw. You can go step on a Lego.
Bye, everyone.
Have a great day.